everyone, how are you? All you are safe and happy at your home. Let us start the physics first chapter, which is nothing but a wave optics. Already in 11th standard you have studied the different properties of light such as a reflection, refraction, dispersion. Okay, now in this chapter we have to study the next properties of the light. First, we have to study the nature of light. Different scientists came up and he gives the nature of light. First scientist is nothing but a Newton's scientist. He gives the theory, and that theory is called as a Newton's corpuscles theory. According to this theory, light consists of a particles. That particles are called as a corpuscles. These particles are the minute, rigid and weightless. Of course, the second point of this theory is these particles are produced from the source of light. Third assumptions of this theory is, according to Newton's, different colors of the light are different size of the corpuscles. Do you understand what I am saying? Corpuscles means particle of the light. That particle of the light is called as a corpuscles. Okay. Then, according to this theory, he gave the different assumptions. Next assumption is nothing but he could not explain the different properties such as a diffraction, interference of the light. But he could explain the reflection, refraction of the light, and therefore this theory is rejected and new theory is came. That theory is called as a Huygens wave theory of a light. But according to the corpuscles, light consists of a particles. That particles are called as a corpuscles. This is the main point of this theory. Okay, therefore he confirms the wave particle nature of a light. The next theory is nothing but a Huygens wave theory of a light. Next theory is the Huygens wave theory of light, and it is very important. Okay, then what is the light? According to the Huygens, light is propagated in the form of a wave. Means लाईटच्या ज्या काही प्रॉपर्टीज आहेत त्या कशाच्या बरोबर असणार आहे? वेव्हच्या प्रॉपर्टीज बरोबर असणार आहे. वेव्हला कोणकोणत्या प्रॉपर्टीज असतात? इट हॅज एम्प्लिट्यूड, इट हॅज वेवलेंथ, इट हॅज फ्रिक्वेन्सी. All these properties are exhibited by the light. Therefore, main assumptions of the Huygens wave theory is nothing but a light is propagated in the form of a wave. Okay. Second assumption is, of course, these light waves are produced by the source of light. That may be the sunlight, that may be the tube light, that may be the bulb. These light waves are travel in different directions with a velocity of a light. Next point is, different colors of the light is due to the different wavelength of a light. You know that white light consists of 7 different colors. Okay, and that colors are due to the different wavelength of the light waves. Means red light has a different wavelength, violet light has a different wavelength, orange similarly, yellow similarly, blue. Okay, next assumption is nothing but a. According to this theory, the velocity of light in rare medium is greater than the velocity of light in denser medium, and it is very important assumption, and this is proved experimentally also in the laboratory later on. Before that, the Newtons confirmed that the velocity of light in denser medium is greater than the velocity of light in rare medium. But this was rejected. This was not proved experimentally. Therefore, Huygens confirmed that the velocity of light in rare medium is greater than the velocity of light in denser medium. Also, this theory explains reflection, refraction, total internal reflection, again interference, diffraction. All these concepts are defined by the Huygens. Only he could not explain the many phenomena of light such as a photoelectric effect, Compton effect, and rectilinear propagation of a light. This is the one of the drawback of a Huygens wave theory of light. What is the drawback? He could not explain many phenomena of light such as a Compton effect, photoelectric effect, and rectilinear propagation of a light. Okay, next drawbacks is, for the propagation of light, ether medium is necessary. But this ether medium doesn't exist in the nature. This is the one of the drawback of a Huygens wave theory. असं असलं तरी Huygens wave theory of light ही जगाने काय केलेली आहे, मान्य केलेली आहे. This was accepted by the world, and according to this theory, the light has a wave nature. Therefore, we can say that the light has a dual nature. Dual means two particle natures as well as a wave nature. Okay, now next theory is Maxwell electromagnetic theory. According to the scientist Maxwell, what is the light? Light is electromagnetic waves. E for electric, M for magnetic. It is the combination of both the field, electric field as well as the magnetic field. This is the first assumption of Maxwell electromagnetic theory. What is that? Light is a electromagnetic waves. Second assumption. These electromagnetic waves travel with the same velocity as that of light. You know that light has a velocity of 3 into 10 raised to 8 meter per second. Therefore, these electromagnetic waves has a velocity which is nothing but a 3 into 10 raised to 8 meter per second. Okay, then third point is these electromagnetic waves travel in medium as well as in vacuum. These are nothing but a three main assumption of Maxwell electromagnetic theory. बघा, डिफरंट सायंटिस्टनी डिफरंट इन्फॉर्मेशन आपल्याला लाईट बद्दलची दिलेली आहे. न्यूटन्स या सायंटिस्टने सांगितलंय की लाईट कन्सिस्ट ऑफ पार्टिकल कॉल्ड एज अ कार्पस्कल्स. हायजेन्स या सायंटिस्टने सांगितलंय की लाईट इज प्रोपॅगेटेड इन द फॉर्म ऑफ ए वेव्ह. मॅक्सवेल या सायंटिस्टने सांगितले आहे की लाईट इज ए इलेक्ट्रोमॅग्नेटिक वेव्ह. ओके, नाउ नेक्स्ट थेअरी इज प्लॅंक्स क्वांटम थेअरी. Planck's quantum theory. Now, according to this theory, light is propagated in the form of a packets of light energy, and that packets are called as quanta or photons. Planck is the name of the scientist, and according to this scientist, light is propagated in the form of a packets of light waves. That packets are called as a quanta or photons. Means they are also the particles. Okay. Energy of each photon. Energy is given by the letter E. You know that very well. Which is equal to the h into nu. Where E is nothing but a energy of particle, h is nothing but a Planck's constant, and nu is nothing but a frequency of radiation. Nu, this symbol is very important. Nu हा symbol नेहमी frequency of light radiation साठी वापरतात. तिथे तुम्ही n वापरू शकणार नाही, f वापरू शकणार नाही. जनरली आपण n आणि f हा frequency साठी वापरतो, परंतु that is nothing but a frequency of a particle. And that nu is nothing but a frequency of a light waves or frequency of a light radiations. Okay, these are nothing but a important points related to the Planck's quantum theory. Again, there is the Einstein's theory. Again, this Einstein gives the informations about the light. Light has a same velocity as that of the 3 into 10 raised to 8 in meter per second. Okay, लक्षात आले हे सगळे पॉइंट्स. फर्स्ट इज नथिंग बट ए न्यूटन कॉर्पस्कल्स थेरी, सेकंड इज नथिंग बट ए हायजेन्स वेव थेरी, थर्ड इज नथिंग बट ए मैक्सवेल इलेक्ट्रोमैग्नेटिक थेरी, नेक्स्ट इज नथिंग बट ए प्लैंक्स क्वांटम थेरी. Okay, and one point is clear that the light has a dual nature, which is nothing but a particle nature as well as the wave nature. Again, the light has transverse waves. Which waves? You know that the waves has a two types, longitudinal waves and transverse waves. This light has a wave nature, and that wave nature is nothing but a transverse waves. Okay, now next point is nothing but a wave front. Let us draw figure related to this. This is the point source S. This produces the light waves as this. Okay, this is nothing but a distance c into t. This is the point source S. Therefore, this point source S produces the light waves in all directions. आणि एका ठराविक एरियावर त्या लाईट वेव्स ह्या एकाच वेळेस येऊन मिळणार आहे. That concept is called as a wave front. Same time लागणार आहे. पहा, this is nothing but a radius ct, this is nothing but a radius ct, this is nothing but a radius ct, where c is nothing but a velocity of light and t is nothing but a time. इथे लक्षात, जसं सन पासून आपल्याला जे काही लाईट वेव्स मिळतात त्या ऑल डिरेक्शन्सला मिळतात आहे, आणि त्यापासून जो काही वेव्ह फ्रंट फॉर्म होतोय दॅट इज नथिंग बट ए, इट इज कॉल्ड एज ए स्पेरिकल वेव्ह फ्रंट. Spherical wave front. Therefore, what is the wave front? Wave front is nothing but a locus of all the points of medium at which the waves reaches simultaneously at the same phase. प्रत्येकाचा जो काही फेज असेल तो सुद्धा काय असणार आहे, सेम असणार आहे. Waves are in phase or out of phase. In phase means crest over crest and thrust over thrust असेल, and out of phase means thrust over crest or crest over thrust असणार आहे. Okay, therefore what is the wave front? Wave front हा असा सरफेस आहे की ज्या सरफेसवर लाईट वेव्स ह्या एकाच वेळेस येऊन मिळतील. दॅट सरफेस इज कॉल्ड एज ए वेव्ह फ्रंट. लिसन अगेन, व्हॉट डू यू मीन बाय वेव्ह फ्रंट? Wavefront means a locus of all the points of medium at which waves reaches simultaneously at the same phase. Okay. Therefore, आता हा जो काही शेप आहे तो आपल्याला कशाला दिसलेला, आपण जर तो जॉईंट केला तर तो कसा दिसतोय? स्पेरिकल दिसतोय. आणि therefore that wavefront is called as a spherical wavefront. Okay. Now this wavefront has a 3 types. First one is nothing but a spherical wavefront. Okay, types. First, spherical. Second, plane. And third, cylindrical. First we see spherical wavefront. What is the spherical wavefront? In the case of spherical wavefront, point source is a sun. म्हणजे सन पासून आपल्याला ज्या काही वेव्हज मिळणार आहे, सन पासून आपल्याला जो काही वेव्हफ्रंट मिळेल तो कोणता असणार आहे? तर स्पेरिकल वेव्हफ्रंट. म्हणजे कंडिशन्स काय स्पेरिकल वेव्हफ्रंट साठी? तर सोर्स शुड बी द पॉइंट सोर्स. ओके. Then next one is nothing but a plane wavefront. Plane wavefront means small part of the spherical wavefront can be considered as a plane wavefront. Plane wavefront साठी जो काही सोर्स असणार आहे तो इन्फिनाइट डिस्टन्स वर असणार आहे. स्पेरिकल वेव्हफ्रंट साठी सोर्स जो का आहे तो फायनाइट डिस्टन्स वर असणार आहे. हा फरक लक्षात घ्यायचा. ही डिफरन्स पण बऱ्याच वेळेस परीक्षेमध्ये विचारला जातो. डिस्टिंग्विश बिटवीन स्पेरिकल वेव्हफ्रंट अँड द प्लेन वेव्हफ्रंट. तर इन द केस ऑफ स्पेरिकल वेव्हफ्रंट द पॉइंट सोर्स इज ॲट ए फायनाइट डिस्टन्स अँड इन द केस ऑफ प्लेन वेव्हफ्रंट द पॉइंट सोर्स इज ॲट ए इन्फिनाइट डिस्टन्स. येते लक्षात? सन असेल, सन पासून आपल्याला जवळच्या अंतरावर कोणता वेव्हफ्रंट मिळणार आहे? स्पेरिकल वेव्हफ्रंट मिळणार आहे. परंतु तो स्पेरिकल वेव्हफ्रंट अर्थवर येईपर्यंत त्याचं कन्व्हर्शन कशामध्ये होणार आहे? प्लेन वेव्हफ्रंट मध्ये होणार आहे. आणि therefore this plane wavefront can be shown by the 2 parallel lines. This is nothing but a plane wavefront and this is nothing but a direction of propagation of the waves. Okay. Now third point is nothing but a cylindrical wavefront. Cylindrical wavefront is nothing but a, if the point source is linear then you get the cylindrical wavefront. Example कोणतं सांगता येईल cylindrical wavefront साठी? ट्यूबलाइट. ओके, ट्यूबलाइट दाखवताना सपोज आपण अशी दाखवली या पद्धतीने. ओके, these are nothing but a waves. If you join this you get the cylindrical wavefront. Means all these are nothing but a types of a wavefront, spherical wavefront, plane wavefront and a cylindrical wavefront. Okay, therefore let us see again. Do you understand this? Wavefront and its types. See this again. What do you mean by wavefront? Wavefront is nothing but a locus of all the points of medium at which the waves reaches simultaneously at the same phase. ही conditions आहे. Then there are the 3 types of wavefront: spherical wavefront, plane wavefront and cylindrical wavefront. Spherical wavefront साठी source should be the point source. Example is nothing but a sun. Second one is nothing but a plane wavefront. Small part of the spherical wavefront it can be considered as a plane wavefront. Third one is nothing but a cylindrical wavefront. In this case, point source should be linear. Example is nothing but a tube light. And last point is nothing but a wave normal. Let us see the definition of a wave normal. You know, normal means yes, perpendicular. Okay, and therefore wave normal, the perpendicular distance to the wavefront is called as a wave normal. Let us draw the two figures for spherical wavefront as well as the plane wavefront. Suppose this is nothing but a source S. From this we get the spherical wavefront. Okay, and this is nothing but a wave normal. What is this? Perpendicular drawn to the surface of a wavefront. This is nothing but a spherical wavefront, and this is nothing but a wave normal. Wave normal. A perpendicular drawn to the surface of a wavefront is called as a wave normal. Similarly, for plane wavefront. Plane wavefront is always denoted by the two parallel lines. These are nothing but a normal to the plane wavefront. Therefore, perpendicular drawn to the surface of a plane wavefront is called as a wave normal. Again, it gives the direction of propagation of a light. Wavefront carries the energy from one point to the another point, and wave normal gives the direction of propagation of light. Okay, let us stop here.